It's hard to believe that something so viscous, sticky, smelly, and unappealing looking as crude oil can be used to create so many useful products and thus be so valuable. So many products can be made from crude oil because it is a soup of different types of hydrocarbon molecules, each of which has its own set of unique chemical and physical properties. And these properties make each particular type of hydrocarbon in crude oil either a good fuel, a useful fluid, or a useful solid. The goal of oil refining is to decompose the crude oil into separate streams of these hydrocarbon types. And the principal chemical process that makes this rather amazing separation possible is fractional distillation. This is the type of tower in which fractional distillation of crude oil is carried out at in an oil refinery. Known as a crude distillation unit, it can be hard to pick out among all the other large and complex units that make up a refinery, but it is the heart of a refinery. Before crude oil enters the distillation tower, it is essentially vaporized by passing the crude through a boiler of superheated steam. The vaporized crude is then issued into the base of the distillation tower, where it begins to rise and cool towards the temperature of the atmosphere at the top of the unit. As the vapor cools, hydrocarbons with different boiling temperatures precipitate out of the vapor. The hydrocarbons with the highest boiling points, which are made up the longest chains of hydrogen and carbon atoms, precipitate out first near the bottom of the tower. The hydrocarbons with the lowest boiling points, and which are made up of the shortest chains of hydrogen and carbon, precipitate out last at the top of the tower. Collection of the precipitates is accomplished using trays located where temperatures in the distillation column are just below the boiling points of the major types of hydrocarbons in crude oil. These trays are punctured full of holes that are topped with bubble caps, which act like a loosened cap on a soda bottle. Rising vapor passes through these holes and out from under the bubble caps, the edges of which drip those hydrocarbons that precipitate out at that particular temperature in the distillation tower. The trays direct the separated streams of fluid hydrocarbons out of the distillation tower to other units in the refinery where the separate hydrocarbons often undergo further processing. Precipitating at the top of the distillation tower are the liquid petroleum gases. Consisting of hydrocarbon molecules containing 3 to 4 carbon atoms, these liquids become gases when compressed into pressurized containers for use as fuels. The principal liquid petroleum gases are butane, found in lighters, and propane, used in grills and camping stoves. Next down the distillation tower are the naphthas. These are hydrocarbon molecules containing 4 to 12 carbons. Naphthas are the principal feedstock for gasoline, the primary fuel used for transportation here in the U.S. Naphthas are also used to produce petrochemicals that in turn are used to create solvents, detergents, adhesives, pesticides, synthetic rubbers such as in tires, synthetic fabrics such as nylon and polyester, and all sorts of plastics from packing to containers and machine parts. Kerosene, which is distilled below the naphthas, consists of molecules with 12 to 16 carbon atoms. The dominant use of kerosene is as jet fuel. Outside the U.S., kerosene is also used as a fuel for home heating and lighting. Following kerosene are the distillates, which are hydrocarbons with 15 to 18 carbon atoms per molecule. The most valuable of these distillates is diesel fuel, which is the dominant fuel for transportation in Europe and elsewhere in the world. Other heavier distillates include the heating oil still used in homes in the northeastern U.S. Heavy fuel oil and lubricants come next. These are hydrocarbons with 19 or more carbons per molecule. Principal among the heavy fuel oils is bunker fuel, which is used in large transport ships. The lubricants reduce friction between surfaces that come into contact with one another and so are critical for smooth operation of machines such as engines. Finally, there are the solid hydrocarbons, which consist of long hydrocarbon chains with 25 or more carbon atoms. These residuals, which emerge from the bottom of the distillation tower, include waxes, such as found in crayons, and bitumen, or asphalt, which is used for building roads and waterproofing roofs. When the total volume of products produced from a standard 42-gallon barrel of crude oil is tallied up, the entire volume of the barrel can be accounted for. Here in the U.S., the greatest fraction of that barrel, some 46%, goes towards making gasoline. As much as possible of the remainder goes towards making other high-value products, such as diesel fuel. However, just about every product produced from a barrel of oil has value and is sold.